So, parametric equations here, question 136. So the first pair of parametric equations, here and here, the easiest way to find a Cartesian equation is to rearrange this one to find a value of, to find an expression for t, and then substitute that into the other equation. So when I rearrange the first equation, I get an expression for t there. Substituting that into here and here, I get that. Now, the question asks to find a Cartesian equation, so that would be sufficient for the examiner, but I've just chosen to simplify that to make it look a little tidier. Okay, so the second equation is the second pair of equations has got cos and sine theta in it. So I can rearrange each of these equations to get an expression for cos theta and an expression for sine theta. So the first one rearranged gives me that expression for cos theta. When I rearrange the second one, I get this expression for sine theta, and then I can join these two together using the Pythagorean trig identity. Sine squared theta plus cos squared theta equals 1, and that gives me that equation there, a nice ellipse. Okay, so the final pair of trigonometric equations, I've got cos and sine here, so I might be tempted to do the same as part B, but the difficulty is I've got sine of 2 theta here. So using the first equation, I can rearrange that simply to get an expression for cos theta, but then I'm going to use the double angle formula for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So I've got an expression for cos theta. I need an expression for sine theta. Okay, so I can use the Pythagorean trig identity again. So if sine squared theta plus cos squared theta is 1, then sine squared theta plus, well, cos squared is x over 3 squared equals 1. And that gives me this expression for sine theta. Okay, so now I can deploy the double angle formula for sine. And I can put my expression for cos theta there, and my expression for sine theta there. And there it is, y equals that thing there. That is sufficient because we've been asked to find a Cartesian equation. But once again, I've decided to tidy this up a little bit and do the following. So there we are, a rather neater version of the expression, the Cartesian equation. So there we are.